Okay, we know what the characteristics are of our two types of polynomials. We have odd functions and we have even functions. Now let's talk about a couple of more things that we need to understand. That's the real zeros of a function, the multiplicity, and the turning points. So here I have what looks to be like an odd function, and one of the things you want to understand about a polynomial function is that yes, they go off in opposite directions in this particular case, but we can have a whole lot going on in between their end behaviors. We can have places where we cross or possibly touch the x-axis, which would indicate a zero. We have multiplicity on those zeros, and we have turning points on the graph. So the first one we're going to talk about are the zeros of a function. Now, understand when we are dealing with the zeros of a function, R is kind of a designation for the zero. So R is a real zero of a polynomial function. R is the x-intercept of our graph. X minus R is the factored form of that function. And R is a solution to the equation. So what that really means to you, when I say the word real zero, x-intercept, and solution to a function, all of that is talking about the exact same thing. So you want to make sure that you're understanding the right vocabulary. Also, if I find out that the x-intercept is at x equals 3, then in its factored form, that looks like x minus 3. Okay, so let's use that information and work this example here. I want to find the roots of the polynomial function, and it looks like 3 times x plus 5 times x plus 2 quantity squared. Okay, so all I'm being asked to do is find the roots. Well, what does that mean? Again, that means for me to find the x-intercepts, or in other words, find the solution. And how do we do that? We take this function, set it equal to 0, and solve. So I'm going to rewrite that down here. This looks like 3 times x plus 5 times x plus 2 squared equals 0. Well, anytime I have a function that's factored equal to 0, I can apply that zero product rule that says each of these factors can now be set equal to 0 and solve each of the factors individually. And that only applies, it's called the zero product rule for a reason, when I have factors equal to a 0. So over here, the first factor, which is a 3, is equal to 0, which doesn't even make sense. It's just a constant, so that's gone. Here I have the next equation that says x plus 5 equals 0, so subtract 5, and we find out that we have a root or an intercept or a solution at x is equal to 5. The third one that we're going to solve down here says x plus 2 squared equals 0. We're going to take the square root of both sides, because I have a squared term equal to a constant, and when I square both sides, that gives me just x plus 2 equals 0, or x is equal to negative 2. So from this I can understand that this function here has x-intercepts or roots that are occurring at x is equal to 5 and x is equal to negative 2.